Okay, so this is Computer Science 475, and today we're going to be talking about manipulating the view. In visualization, it's important to change different aspects of what you're looking at. And this particular chapter in the Munzner textbook deals with methods of doing precisely that. We'll look at how to view changes over time, select certain elements that we want to examine, and navigate to subsets of data items that interest us. So as always, Munzner starts out with the big picture. And as you might expect, there are several different design choices available to us for manipulating the view. In theory, you should be able to change any aspect of the visual encoding. And one way to manipulate the view is to show changes over time. And you've seen this with tools like Gapminder. When we looked at things like life expectancy per country over time and did the animation, you could see different countries rise up in terms of their life expectancy. You could also see them fall down during events like World War I and the Spanish flu pandemic. That's a really powerful way of showing things. But a change requires items or attributes to be used as input. So there's often a need to select to determine what to manipulate or to get further details. The final broad category of view manipulation is navigation, which is a change in the viewpoint. That is changing what's shown in a view based on the metaphor of a camera looking at the scene from a movable point of view. This can either be through item reduction or through attribute reduction. So there's two different ways of affecting that type of change of viewpoint, either reducing the number of items that you're showing or reducing the number of attributes shown. And in terms of attribute reduction, it can often make tremendously complex visualizations a lot simpler when you remove attributes from the viewpoint. So it's a worthwhile one to explore. So changes over time is probably the most common way to do this, and data sets are generally large enough that you can't show everything at once. In general, the possibilities for view changes are the same options you have when constructing those views. You can change the encoding, arrangement, order, the viewpoint, or show that change over time. If you're looking at multiple items such as data from multiple countries, I'm a big fan of the animation and movement that you find in tools like Gapminder. Of course, you don't always have that option. Sometimes animation can take away from things. And again, this is more the art side of things. You can also do things like switch to completely different idiom to show the change over time, although that has its own challenges from a design standpoint. Another way of changing over time is give the user control over how to encode things. This tool is actually called Lineup, and it's designed to support exploration of tables with a lot of attributes through interactive reordering and realigning. In addition to sorting by individual attribute, the user can sort by complex weighted combinations of multiple attributes, such as the university rankings that you see here. So here we have the top 25 universities, and the person who made the screen capture has highlighted Princeton. The red corresponds to the school's academic reputation. Green is faculty quality. And after the first separator, you see their 2012 ranking. After the second separator, you see the 2011 rankings. And after the third separator, you see the 2010 rankings. So you can see how Princeton's reputation has changed over time. If you're paying attention, I made a slight modification to the diagram and see if you can find it. Animated transitions. This figure shows an example of 5 different frames from an animated transition of a network shown as an adjacency matrix. So we've taken the 5 different frames and put them out in order. The data type shown is a compound network where there's a cluster hierarchy associated with the base network. Transition shows a change from one level of hierarchical aggregation to the next, providing more detail at each step. Accordingly, the scope of what is shown narrows down to show only a subset of what is visible in the first frame. We also stretch out to fill available space while the other attributes squish down. And animated transitions are useful between states, obviously, and you can use jump cuts, such as showing them one at a time, flashing them up. But slower animated transitions help the users maintain the connection between the different states, like we're seeing with these animated PowerPoint bullets coming in. And it's best to use animation when there are a limited number of changes or when things move together in a group, and don't overdo it. I kind of overdid it with this slide, but that was more to illustrate the point of not overdoing it. Selecting elements is another way to change the view if you want to look at one particular element or a few different elements in particular. This type of changing view or view manipulation supports nearly every interaction idiom. The output of the selection is usually the input to the next operation. A fundamental choice is what you can select as a target. Can you select elements, links, or attributes? Or, are you allowing the individual to select all three? Another critical design choice is the number of selection types. Typically, you can only select one element, but there's tools such as doing a shift click that allow you to select multiple tools or multiple elements. And a final choice is how many elements can be in the selection set. So you may want to select multiple items and make them into a group and then look at that group in particular. Say I was wanting to look at all my top students, I could select a group of top students and look at them in that set. Another tool for view manipulation is highlighting, and that means changing the elements in some visual way. So you give immediate feedback when that's done, because it's important that you've actually shown that you've highlighted, just like the Sharpie going across the second bullet point there shows the highlight. And the most common highlight choice is to change the color. You can also highlight using outline, size, motion coding, like make the object move back and forth a little bit or spin. Attributes can also be highlighted if they're represented by marks. So you can highlight not only elements, but attributes. So changing viewpoints, large and complex data sets you can usually understand them from just a single point of view. So navigation allows you to change the points of view from which things are drawn. And I usually don't go for motivational posters, but the one that you see here is actually quite good. So there are three components to navigation: zooming, which moves the camera closer or farther away from the plane that you're inspecting. Panning moves it parallel to the plane of the image, either up or down or side to side. And rotation spins the camera around on its own axis. Rotation is very, very rare in 2D animations, but it's much more important in 3D motion or virtual environments. So there are a couple different types of zooming. One is geometric zooming, which is moving things closer or farther, that you see with the bicycle there, where in the upper left, we start with the photo of the bicycle doing the jump, and then we zoom in the lower right to see a close-up of the rider's motion and posture. Semantic zooming changes the representation of objects based on the number of pixels available. An example of this is Windows Explorer for files. So, here we see the file structure for the CS475 class. If we scroll in with our mouse wheel to zoom in, we can actually see larger view of those individual files and folders. And that's an example of semantic zooming. It also changes what information is available. So larger icons give less information available, whereas the smaller ones give the date modified, the type, and the file size. Navigation is another way for changing the view. Unconstrained allows you to move anywhere. And it's easy to implement unconstrained navigation. That's the good news. The bad news is most people have trouble using all 6 degrees of freedom. So the 6 degrees of freedom are forward, back, left, right, and up and down. And when you get people lost in virtual environments, the camera oftentimes ends up looking at nothing. And constrained navigation alleviates that problem to a certain extent by placing limits on the camera orientation. For example, limiting the zoom range or the degrees of freedom. You can't go up and down. You're stuck in 4, you're stuck without flying. And you can see the problems that people have using all the degrees of freedom. When you watch people muck around with virtual reality for the first time, you're keenly aware of how difficult it is to use all those degrees of freedom. And I wish we were doing this in person, because I could put the VR headset on different people and see how they maneuver around in that virtual reality. And it can actually be quite disorienting at first. Another tool for changing the view is reducing attributes instead of items. And you can use navigation to reduce the attributes, that is the dimensions. For example, slicing, which we see here. Figure A is an axis-aligned slice of a brain scan, while B is an axis-aligned cut. While the axis slices are most familiar to users, slicing is also possible in higher dimensions. So the slice is a single value chosen from the dimension and then eliminated. A cut is a position of plane that divides the viewing volume into two. And another way of reducing attributes is using projection. So this is most common in geometric applications. All the items are shown, but without the information for specific dimensions that we choose to exclude. For instance, the shadow of an object on the wall or floor is a projection of 3D to 2D. When you're looking at your shadow, you're probably also familiar with different map projections, including the most common Mercator projection. And in 1569, Mercator built a whole world drawn along colonial lines, and that's literal. The biggest economic powers were given space on the paper to flex their border biceps, and the problem with that is it's not to scale. In particular, Greenland is not that big. Africa is actually 14 times the size of Greenland. Although, from elementary school, we're used to thinking that Greenland is the biggest thing in the world. There are a bunch of other projections that emphasize different things and will change your view of the world. Take a look at the Gall-Peters projection to see how big Africa really is. So depending on where you project and how you project, you can get very different views of the world. Okay, so thanks so much for watching, and we'll be back next time to discuss color.